And I have a series of questions, but we may get into discussions that abrogate this having to use all my questions. But the first one is, what are the technologies now on the horizon that will significantly change how we measure and solve our problems in golf in the future? And I'll just preface that with usually discoveries, changes, paradigm shifts. In advance of those come technology changes, such as the electron microscope and those kinds of things. So we have people on the point of the spear here in technology, and I'll throw that out to the panel. Maybe you'd like to start on this end. What kind of technologies would you like to see in the future that would be helpful in your area?
Should I start on that one?
You can, sure.
I've always had this, ever since I got involved with motion analysis systems 30 years ago, I've always had a vision that there would be something I like to call the magic camera. And that magic camera, basically you point it at the person and you get all the 3D data that you want. That's been a dream, but it's coming, because who's got kids who've got the Microsoft Kinect at home? If you played with the Microsoft Kinect, that is a view to the future as far as I can see. The camera points at you, it outlines your entire body, it creates a three-dimensional mesh on your body, it puts a skeleton inside your body, and then it's able to measure all of the body angles in real time without having to do as you've probably done if you've got an AMM system, doing all the digitizing the body points. So consequently, that will, in the future, allow us to get much more information more rapidly without having to do the tedious setup that we have to do. I think there's several things that have been restricting biomechanics from my point of view, and one is the tediousness of the setup, the exactness of the setup, and the expense. The Microsoft Kinect is about $100 now, so it's taken away the expense aspect of it. There is still an aspect of the setup, because unfortunately it's still very difficult to get the data without some form of setup or some form of sensor attachment to the body. Has anybody heard of a system called Organic Motion? There's a system back east now, and they started doing that. I went to a SIGGRAPH conference, which is a graphics conference every year where they show all the motion capture systems. And they had a booth set up where you could actually go into the booth, stand there, put your arms out in the pose like that, and then it would lock the avatar onto you. And an avatar is just basically a robot or a figure and it clicked onto you, and then you could move and dance and jump around, and you would see on the screen you moving. So you were the motion capture driver at that point. And I was very excited. Dr. Greg Rose was with me at the time, and we were looking, going, wow, this is really the future. Unfortunately, one of the things, they wanted $80,000 for it, so it was a little expensive. But then we thought, okay, can it do the TPI screens? So I was up there like that, and I'm standing like that, and then I did this, pelvic tilt, and it just stood there and looked at me, and it didn't move. It didn't know that I was doing the pelvic tilt. I put my arms out like that, and I went like that, and it didn't know what I was doing. So the problem is for general gaming situations and what do they call it, first-person shooter type things and those sorts of games, I think the technology's there now. But I think that what's going to happen is we're going to have a hybrid solution. And what I mean by that is we're going to have something like a magic camera, like the Kinect, but we're going to also have something like an AM sensor or a K-Vest sensor as well. And those sensors are going to get to the stage where they'll be sewn in to your clothes. They'll be in your glove. They'll be in your clothes. And they will double check what the video sensor can see. So the two will work together, and we'll have a hybrid solution. And I think that won't be more than 2 or 3 years away.
You'd sync that to measure outcome measures as well?
Yeah, well,
it'd be nice if you had both.
I come from the body point of view. So yeah, you still have You still have the club head and the ball. You've got to have the outcome measures. I absolutely agree with that.
Let me direct the question to you, Dr. Bob.
Well, then I'm not going to ask any more questions or make points if you're going to question me.
If you had an exoskeleton that could fit over the body in some way, reacting like he just outlined, what implications would that have? And we're not talking about measuring data now. This is measures data, and you can think. I'm talking about motor learning and syncing firing patterns, creating firing patterns. What would be the role, if any, of an exoskeleton that actually made you swing perfectly?
Made you swing?
Made you swing.
Or provided you with feedback that helped you swing?
Either way.
Either way. The way I see it right now is you can, if this system were to come to being, and we have systems like that right now with TrackMan and the 3D stuff. The question always for the instructors is, how much do I give to my students directly? Do they need to see this, or do I take this information, interpret it, and then put it in a usable form by the students to help them make the change? Most of the time, the more sophisticated the data and the measurement system, the more meaningful and useful it is for the experts, the instructors. Unless you have an advanced player who has learned how to use the system, then he or she could do that themselves because they take over your role. But the interpretation of the more sophisticated data that you're getting, more detailed data, would be interpreted by the instructor then. And some of you are doing that now with TrackMan, right? I mean, you're not showing all this stuff to each of your students every time you do it. Sometimes you're just confirming what you see, or what you think the video is showing, or whatever, by angle of attack and all the other things that you're getting. And that's kind of been the history in the learning field, that just because something gets more sophisticated and more precise in terms of measuring something doesn't mean that it necessarily enhances learning unless you know how to use those data that you're getting. And in this case, I think if this advances, it's great for all the instructors, because now you really know what's going on. The trick for you in the art of teaching is to decide how you're going to take things like swing path, minus 20 degrees, or angle of attack, or whatever you're looking at, and say it in a meaningful way, in an artful way, to get that student to change what he or she is doing.
Would it be
and
possible?
then it changes from student to student as well.
Would it be possible in the future to eliminate golf instructors, to have a machine like Woody Allen's time machine where you stepped in there and it was an exoskeleton that forced you to swing exactly while it was programmed, and you did it and did it and did it, and you stepped out?
Yeah,
and
people have learned golf swings and how to play the game without instructors. That's happened before technology has come. Okay? So, can you learn a golf swing without any of this technology? Absolutely. Is it a good golf swing? It may be functional for that person. It may not be perfect biomechanically, but you can do that. So if you can do it already now without it, there's no reason to think that if you're provided with some kind of feedback or constraints, and if it's practiced the right way so that you come off the constraints, and are able to generate that you can't do it. So yeah, I think it could help.
Peter, what do you think about the muscle part of it? How would you?
Well, I would have to comment that I don't think you guys have to worry about becoming obsolete anytime soon, because the human computer is going to far outlast any technology when it comes to making fine adjustments. I've had the same question asked. Well, maybe we could teach a machine how to do chiropractic adjustments, possibly, but the intricacies of interpreting movement. And the idea of an exoskeleton, I mean, that seems like the details that would have to go into that to put a body. Who's going to determine how you're going to make that body move? So that would be my comment. You're not going to lose your job anytime soon.
Do we have a consensus on what is a biomechanically perfect movement pattern?
Maybe somebody should write a book called A Search for the Perfect Swing. Then we'd find out. Yeah.
We had, 15 years ago, motion entry. And the reason it had motion entry, if you got injured in an accident, you took actually figures to do wrong when we moved it and things. So it was a legal defense mostly. But I spent, I'm going to probably die of cancer or something next week, but hours. And it showed every single joint movement. And we thought that each one of the thoracic segmental leads, biggest surprise was that all of them turned at one time. So we had this motion X-ray, and what David was saying, each joint has a certain range of motion. There is a best way to move. And to have a biomechanically clean swing is not hard. I mean, it's an absolute finger, attaches to the finger, ligament, muscle, tendon, structure, mandates that advantage one direction. Laws of physics don't change. So if the joints are normal, and everybody, everybody's different. Well, we all got 10 fingers, we all have a range of cholesterol, and all of our methods. So really, basically, are all the same, because we've got defects. So I believe there is a best way to swing. I'm not familiar with motion, it's unbelievable. The problem is you get moved.
Carl, you just nailed it. I've worked with motion X-ray for years, and I can take everybody's neck X-ray in this room, be a little different. Now, there's a perfect motion for everybody, but hardly anybody's going to have that. So if you're going back to how you're going to get the perfect swing from some kind of a model, everybody's neck is different. If your joint motion was perfect, yeah, but it's not going to be. So that's a big problem.
When a guy loses his full range of motion, we're all born with it.
But you're talking about, when you're talking about the neck, for example, you've got segmental motion. So you've got degrees of freedom for each segment. And when your curve changes a little bit, it's not going to be that perfect flow that I was talking about yesterday.
I don't have enough range of motion.
Everybody's neck's getting stiff.
Michael?
So are we talking about 80% of the people that we teach, maybe 70%, that hips, that knees, they can't turn, 50% of a trainer, a physical therapist. So are we talking about this technology being more for junior players, the elite athlete? I mean, I think that's the big question, because there's no way that I could take a 65-year-old guy that's got a bad knee, bad hip, and can't turn through the ball except for him use his hands. So what is good if it's a model?
That's why your job's pretty secure, because everybody.
That's exactly right.
That's right. But I think going back to the feedback, if you can get feedback that will tell you, regardless of the differences among the people you're teaching, that will confirm what it is that you need to have confirmed, put you in a position then to make the changes that help make the changes that need to be made.
Got a bunch of guys back here.
Okay. Before the golf gaspatron is the golf gaspatron is invented. You need to understand a couple things, okay? Everybody has an ideal movement for what their body's capable of, okay? It's not going to be the same for everybody. To try to say that this model works only for this, if you've got a guy who's got only the left arm, he doesn't have a left arm, his movement, obviously he doesn't have that right side. But obviously, we can't, the problem is we need to start thinking outside the box instead of saying, okay, try to fit everybody into one box. I used to try to get everybody in the box and try and did search. 30 years ago, Randy and I were out there on the sewer every week, working with guys. But then we had our guy with Kodak Spin Physics 2000 frames per second, and we talked about 3D and stuff like that. Most analysis, we were using stuff 25 years ago with a lot of stuff. This isn't new stuff. It's just it's more correct.
Right.
And we put hundreds of golf professionals who kept trying to find the golf swing. And you know what we found out? There is the golf swing, but it's different for each person. So then we started looking at what the cost is. And then TJ and I and Jim Setti and stuff, we continue doing it. There isn't a golf swing. There is a golf swing for everybody. But we need to determine what they are physically capable of and then move from there.
I think there's basic biomechanical principles that we have to adhere to, but then how your body can achieve those particular principles is different from one person to another. And that's the problem with the exoskeleton. You could put somebody in an exoskeleton and it could do even the perfect swing for you, but can your body support that as soon as you take the exoskeleton away? You don't have the physical condition, you don't have the strength, the power, the speed. You have to develop all of those things to be able to support that motor control aspect of it. And as far from the motor control aspect of it, there's many different motor control strategies that your body can achieve the same motion.
Okay, let me fast forward to the year 2040 for the group. Is there...
Yeah, who's still around?
I won't be here. Is there, when we look at the golf swing in 2040, given what was just said and what we know, is the golf swing going to look pretty much the same as it looks now? Or is there a really big change that's coming, given the same rules now that you have to stand at the side of the golf ball? Is there one thing that would significantly change the golf swing?
Kevin?
It seems that go back and look at the evolution of golf swings over time, so lots of people around the environment. So all change and equipment change. Go back to the latest that came down from the golf. The old ball swing. We're not going to get the ball swing. Players go like that.
Yeah. But if you parachuted into the 2050 and didn't know you were at 2050 and you looked at the golf swing, would you say, you know, okay, that's a golf swing? Or would it look, is there another way to swing the golf club given wildly different stuff? Like, I will give an example, like no backswing. Okay. Okay. Yeah. Okay. So, but for you in 2050, it would look pretty much the same. We'd say that's a golf swing. Anybody have any other? Yes, Brian.
Okay, so I can answer the last two questions, one answer. So, right now, last year, it's 25-year anniversary of Jack Nicklaus winning the Masters. So they played the telecast. I saw lots of swings where the club finished down people's back. And then they played the last year's tournament. Nobody's club finished down anybody's back. More or less, right? Now, why is it because the swing evolved that way? Or us and a bunch of other guys like us and girls like us taught people to finish together? My contention is, well, some of it's equipment and some of it is us.
It's my presentation this afternoon. Okay.
Well, okay, but here's the reason. Because all this other stuff we were talking about before, we're looking at all these different swings and all these different bodies because we're looking at too much of what the body's doing. That steering wheel that's in your car, right? You could steer it like this, like most of us are going to do, right? And then they got people that are physically challenged, they have a little ball up there, and they steer it this way. But then they got people I've seen that don't have arms, that can drive with their feet. The steering wheel has to do the right thing. Hopefully what's going to happen, you've got TrackMan, but now you've got the Enzo machine measuring the club, the whole swing. When some smart scientists like a Phil Cheatham or Stephen Nesbitt can work the forces out of what's going on with that club, the whole swing, then we can figure out a way to get people to make the club do what the club needs to do. The only thing the ball's going to experience is what the club needs to do. And we keep looking at how Ed swings and how Jim swings, and then I built everything alike. When if we could just measure the club the whole swing, and not only what the club is doing,
Kevin to swing as good as it, let's say.
So is it this?
The whole problem is we're trying to work the problem backwards, and the swing will look a lot different when we realize that we're working the problem backwards. I think it'll look a lot.
How will it look different?
I don't think you're going to see as many swings looking. I think right now, I'd love to hear everybody's opinion of this. I think swings look a lot more right now than 25 years ago on tour, for sure. And I think they're going to look less alike 25 years ago.
I think you're going to see a move to make it what the hands do, develop firms. And I envision, I'm hoping for some stage, I know we're all about teachers, but we're not even trying to talk about swing at all. We're teaching people. If we took it back from many years ago, it's a club and a ball. Take the club, get the ball to the target. And we're going to return something much more simple. Because it's been my experience that people are just overloaded with information and underloaded with skill. I think you're going to see a tactic.
What did you think of the presentations on the driving range yesterday about overloading?
I thought there was a whole lot of talking going on. I just like to see skill development going on.
I think
for the good of the game.
The context really shaped the content.
Well, yeah, that was tough on the head.
Yes, absolutely.
Everybody out there.
Absolutely.
What did somebody out there, that person that didn't know what she was writing about?
Yes. Now that's what I mean by the context shapes the content. Yeah. Yes, Ed.
In 2040, the advances are going to be so immense that at different levels, let's look at it. At the expert level, you're going to have uniformity of swing based on body type, where you can actually go into a computer, list all your height, your weight, your strength, where you're weak, where you're not, and that person can come on and then say what's the most efficient way for that person to swing body type. Whether they do it or not, that's going to be available. The second thing is that as a teacher, just like pilots are trained on simulators, you would be able to punch your students' things into your computer and be able to say the day before the lesson, if I have them hinge earlier in this situation, how is that, what cause and effect, and it's going to come up on your screen. So you can actually, you think about how have you trained, how many years have you trained as a teacher? You could be doing simulations in front of your computer, using your brain, punching in different ideas, and seeing the results instantaneously. Extrapolating it further, that means that the student can buy the same computer, punch in their deal, and potentially do it by themselves. However, the human need for having a coach, for having a mentor, is never going to go away. So even at the highest level of technology, there's still going to be that coach that's going to be there to sustain.
They're already doing that now. They have some fascinating, but Dr. Bob can speak to it, where they catch you, record your brainwave patterns, which are like fingerprints. Let's say putting. And as you are putting, and you are putting well while you're making putts and so on and so forth, there is a specific footprint in your neural patterns. That footprint, once you learn to call it back up, makes you putt well again. It's just the opposite of the other way. And so they could do exactly the same thing with body types. This biofeedback is really coming. Yeah, so, yes?
And if you think that the technology of being able to say this is the optimum pattern for your biomechanical structure and the condition physiology right now, because both of those affect this optimum right now, just helps you get the question answered to the student faster. And when you eliminate, should I do it this way, should I do it that way, then you can get to the performance aspect and say, let's learn skill. So, but it eliminates that question of really is this best for me? And now we can get to performance faster.
John?
The thing that's difficult, just running off of that and some of the things that you said, one of the things that ultimately has to happen is the student's got to be able to repeat whatever it is that you want them to do under whatever conditions they're under, competitive conditions, whether it's on the golf course or they're competing at a higher level. That's tricky business right there. We can make changes that are biomechanically efficient, but if the person can't do this consistently, can't get into the hitting area consistently or make the swing as consistently under pressure as they need to, then they got to go find a way that they can be consistent. And that could deviate somewhat from the most biomechanically efficient way to do it.
When you improve somebody's basics.
John, wait a minute, he was in here. John.
Phil, so we're kind of talking about the future, but coming back to where we are today for just a minute. So with all these biomechanics, what you do, and I spent a lot of time with Rob Neal, all the sensors are on the outside. So let's say, hypothetically, we could insert sensors internally. A, where would that stack up? Or A, have you thought about that? And B, if we were able to do that, what do you think? Do you have any guesses or thoughts on what the numbers of the research would show?
Well, firstly, we put the sensors on the outside of the body because they don't let us stick them on the inside yet, unless we get, a waiver on that aspect of it. But we actually do put the sensors on the inside of the body. That's the whole procedure of digitizing the body. What we do, for example, is if I were to put a sensor on my shin here, I then have a pen with another sensor on it, and I digitize the outside of the knee, the inside of the knee, the outside of the ankle, the inside of the ankle, and I create a new reference frame. Remember I talked about reference frames yesterday? Inside the center of the knee. So as far as the computer is concerned, the data that it's getting is not from this sensor here, but from an internal sensor in the center of the knee. The computer doesn't know that that's on the outside of your body. It thinks it's on the inside of your body. So we do construct an internal skeleton and transform the sensors on the external part of your body to the internal part of your body. That being said, there are going to be errors because of flesh movement, skin movement, muscle movement. So again, unless we could pin the actual sensors to your skeleton, we have to deal with what we've got. But the system, the magic camera that I talked about early on, can also do that because it can take a complete surface of your body, and then it can predict the centroid and the central axis of each part of your body and translates it inside.
Wouldn't it be, I bet every one of these people would agree, and maybe this is a good idea and I'll take 1%, but wouldn't it be great if in any 3D machine that's currently available, I'm talking about 2040, if Ed could say, I would like to see, give Brian a lesson, the point between his hips and his belly button, center mass, how that actually moves in space. It's just simple. It's moving 3 miles an hour toward David. It's moving down.
We do that.
But I'm just saying simply.
Do that.
Software. We think very simply how far did this point move down on the back screen?
We do that. Who was with me yesterday when we were looking at all the swings? I mean, how many questions did you throw at me that I couldn't answer for you? We put let me just...
I'm saying you can do it, but I'm just saying, I've seen people on 3D machines that work with them every day and they couldn't get that.
You can select, okay.
Yeah, select the point, a teacher selected point. Like,
right.
You want to see the difference between the left hip, center and the right hip center.
Like I said, that's all there. Maybe the user interface needs to be made more simple. All that knowledge is there. When we've got that 3D robot, we've got all the internal joint centers, all the internal axes, and you can measure anything. That's the beauty of 6 degrees of freedom. It tells you everything. Now,
brain, and I look at all the charts and all the lines going up, and then maybe it's so you got to list that long.
yeah, the information is complex. There's when you've got a lot of things that you're trying to do, it's got to be simple.
That has to be done on a very tight basis. The guys over at Core got a great seminar from James Light and Ben Shear a few weeks ago, and I talked to Tom Jackson. That was unbelievable. They sat in there and explained exactly what the graphs meant, and it was a tight-knit group. It's not that difficult to get the basics, and once you've got the basics, you can go to your guy and say, look, give me this information. This is what I need.
Yes, Jim.
Bill, when I bought my system in 2006, we did an experiment that we just put one sensor on the left shoulder. Interested that you bring it up. And then you did then you asked me whether you wanted the linear components and so forth, and we tracked that one sensor. And so what we wanted to do was see at the time, just real quick, was to see where was the left shoulder location at impact versus where it was at address. And so that was, and we
we're doing that.
It's not available in the software, you did it because you were there.
Yeah.
That would be a wonderful thing to add to that, because just like I said, we're already measuring the center of the joints, and we're already measuring all that stuff. But it would be really cool if we could, if within that software, we could take one sensor and isolate one particular thing.
Well, the problem with that, and that's a great idea, and yeah, the walkabout system only has 3 sensors to start with, so maybe there should be a mode where you say, hey, I just want to put this on your left eyeball or your left earlobe or your knee or whatever, and measure what the heck that's doing. That can be done, but getting back to the model that you've got, it does have all of those bits and pieces. I think the key here is how do we bring that to the surface in a very simple and easy manner. That's up to you guys. You need to feed back what you need, what you want, how you want to see it. That's all the human factors stuff that we've got to come up with. The data's there.
You know, with this advancement of all the technology, we still have to consider how is the human going to learn the information from the teacher.
That's the key.
And that's the art of instruction. I mean, that is, you know, what you were doing yesterday and trying to do what I want you to do afterwards. Came straight out and said, guess what, if you don't practice, you're not going to get any better. So how are we going to motivate them to try? You know, there's all those issues that are never going to go away regardless of the technology. And I think and I love that we're pursuing technology, but let's not lose the communications, the art of the communications.
Yes.
Well, I mean, the goal is to get the student to come back, build confidence. No?
A little louder, please.
Confidence. Get the student to come back again for another lesson.
You know, I have the same problem with patients that if they focus on their pain, sometimes they think they're not really getting any better. You guys can improve a guy's swing incredibly, but their score hasn't gone down. So if you use objective data to show them things that are improved, that's a good way to keep them on a program. Wouldn't you say, Gary? Go ahead.
I'm not saying so. I have somebody who's pain.
Right.
I send it to you.
Right. No, I'm just using that as an analogy.
But then you tell me.
Pain for you is they're 95 or they're 20 over par. That's their pain. You know, they want to get rid of their pain, right? You can't focus on that. You have to focus on getting them to be as efficient and proficient as possible.
But I think one of the problems we've got here is our outcome measure, and I'm probably going to throw the cat, what's the chicken, the fox in the chickens or whatever with this statement. I couldn't get my analogy correct there. But but anyway, the problem. So, all right. Now you've made me lose my train of thought. Go on. Well, now you've made me lose my train of thought. I'll get back to you in a minute. Carry on.
Well, you're going.
Well, I a couple points. One thing is we're talking about, you know, the best golf swing, except that when we're playing golf, we have to make adjustments for a particular shot to change trajectory, to control distance. So it's not just one motion, there's a variation of this from a playing standpoint. And then the second thing, and I kind of refer to Peter and Phil, do we have, I mean, because there's definitely some variation among teachers in setup. Do we have a functional setup that is best from the standpoint of injury protection?
Can I go back to, sorry, can I go back to quickly, I've got the point that I was talking about, and that was exactly what you were just talking about then. Our outcome measure is our ball flight. And that's kind of unfortunate, to be honest with you, from my point of view, and this might be controversial, because there's a heck of a lot of things that go into making that ball fly in that direction, and I might be working something way back at the setup, and I might change something in my setup, and because I've changed something in my setup, all of a sudden it screws up my ball flight, and I say, oh, that must be wrong because the ball flight's wrong. There must be some performance measures that we can have that build us back to that ball flight, but don't have to have ball flight immediately. I might want to be changing setup. I might want to be changing something at the top of the backswing. That's where we need the objective measure of the 3D system to say, like Peter just said, yes, you have gotten better. You've done this and you're in a much safer, healthier address position than you was because your XYZ is this, that, and the other. But my ball flight's gone wrong. Well, okay, I'm sorry. And I know this is controversial right now, we have to change that first, and now we have to relearn that particular aspect of the swing. I don't know, have a comment on that.
Brian's saying to make TrackMan, isn't it our job to make the TrackMan numbers add up through the changes so they enjoy this whole journey? I mean, you can't just set them up and say, you're going to suck for 2 months until we get down the road and we can improve this whole thing. I mean, we need to be able to do a blend of both.
The problem is you guys always want the quick fix. You always want the Band-Aid fix. You want to be out there and you want to say, great swing, and then they go away and that doesn't stick. Things don't change instantaneously. You have to train it over a period of time, and you have to train it incrementally. Being a gymnast and training for 20 years, I didn't just learn a skill and then I had it for the rest of my life. I had to learn pieces and parts. I had to get stronger. I had to get more flexible. I think that we always want to have it now.
I think as the good teacher, we'll get you're next. The good teacher understands that at some points in the learning process, the ball is tutorial. At other points, the ball cannot be your master. And you have to sell the student on incremental changes that will sum later on to make them better. And then there are some things that if you fix it right away, you will report in the ball flight. You, as a teacher, you've got to know the difference to be able to predict and say, now let's not worry about the ball flight on this because we're working on the grip. When it comes time that you have all your pieces together, then, so sometimes it's the master and sometimes it's the teacher, yes.
I was going to say, a lot of technology is very unique for the PhDs. We have however many sensors we have right now. 20 years from now, we have more sensors that are measuring things. Of course, boards that are on the outside of what we're looking at. We did ball flight. It was a perfect information type of game. We knew everything that needs that ball flight. Lines, work the ball that way. This doesn't take complete information. There's still a lot of speculation going on. That's just why the ball flight sort of centric spectrum.
Anybody else?
Gary? I mean, Peter, you know the patient. How many times did that come to you?
Well,
if they have 16 handicap.
I love what he's saying over here. If you come to me with a sore back and I don't get rid of any of your pain after 10 weeks, well, what good is that, right?
But after 10 weeks.
Once a month. Once a year.
How often would I see a patient?
Yeah.
As many times as I need to get them to a point where they're taking care of themselves. Exactly.
I have a question for the whole group that bears on collecting data, using data to teach, and so on and so forth. And there is a theory that error sums, that small increments in the initial conditions of a system that are not evident to the viewer, to the eye, may be evident to the recorder, but that they begin to sum over a period of time. It's like the butterfly, it's called the butterfly effect. And a guy by the name of Lorenz figured out chaos, all of chaos theory. He was entering in weather patterns and he cut off the last 4 digits because he felt that the computer wouldn't need that. And what he found was after he allowed a lot of iterations of the computer to run, that it made a huge difference in the final effect. Some little perturbation of the system here literally caused a hurricane in Miami, and that really was the basis of the chaos principle. My question is to you, we have the best teachers in the world in this room, is it possible that some very resistant errors, ones that you have difficulty in getting rid of, and we all have them, and they recur and they recur, are a problem with the initial conditions? Very small area, very small perturbations in the takeaway that you don't see. Very small perturbations at the set of the club. Very small perturbations at the top. Not available to the naked eye, but they totally sum to deviations, the deltas that impact. Number one, is that possible? Number two, have you seen that in your own teaching? Number three, how would we take the technology and make it non-chaotic? Well, that's not even a good question, but you know what I mean. Is this possible? Yes, right.
Just to use a TrackMan example, okay, vertical swing plane, that's basically down here, the club head, the center of mass from parallel to the ground, about parallel to the ground. That James was the only person that ever paid any attention that I saw that was in the video realm. But he didn't use it, you know, the way that you would use it. Because of that number changed most of what I'm teaching.
Really?
Yeah, because I didn't know, it wasn't even a number I focused on. So it's like I'm saying, it's something like you're just saying.
There you go.
It didn't exist. Now there's this number. I know what it means now. How do we change this number? Because you got some really good player in front of you, and he's putting up a 54 with one 600 shot. He's putting up a 61 with the other, but none of the other numbers are changing. There's the chaos that wasn't being seen, and then I had to figure out a solution to that. So there's probably infinite numbers of that. Like Chris is saying, the whole, there's so many missing little pieces that obviously the missing pieces are the reason that the game and our profession is still struggling.
And the chaos actually is a misnomer. It actually means under sub rosa there is organization that you can't see. Yeah. Yes.
We see it on the TrackMan. You can see it immediately. Something, a small perturbation at an address. Someone sets up with their shoulders aligned too far to the left for that. And you change that. You know, then all of a sudden you see many of the TrackMan numbers. So it can be real simple stuff like that.
So in your experience then, I'm concerned with the human eye. Phil and I have been talking a little bit about how many degrees, you know, we talk about 10 degrees, 5 degrees. How many degrees can the human eye really see? It's less than you would imagine.
Yeah, this is going to sound bad, but I don't care. I mean that with all respect.
Yeah.
I don't care about the degrees. Okay, take yourself, aim yourself more this way at address. Let's see what happens.
Yeah.
And then we'll see immediately. So, and the person's not.
But how do you reproduce it?
Yeah, but see how you're in a box then.
If they go wrong and you say, well, we're going to adjust again like we did last week, and then you come back and then it's not quite working.
That's right.
You don't have a baseline.
The probabilities are too great.
So I've got a student at address, okay, and I'm going to show the student, okay, at address right now, you're a little bit too far open, and that's why I think that you have a little plane shifting to the left, okay? All right, show me more, show me less. And I'm going to have him keep going back and forth, and I'm going to actually test him while he's doing it. Okay, give me 3 balls. Now I want you to go more close, more close, more close. And I'm going to go more open, square, so that he starts finding his own version of it, and he starts to detect his own errors by showing him.
That's the goal, but what happens when he comes back?
How does that student then reproduce that?
Next week he comes back in. So you go through the whole process next week. And you don't know where he was when he had that magic number, right? And next month it might be a little different. Does it really matter? I don't know.
I think that we're not the same machine every day.
Gary?
Yeah, I mean, Bobby Jones, it was the cages. I mean, look at all the boys, Jack, all the boys.
Well, he might have been able to hit a steel shaft if he'd have had it.
Look at that stance there, gives him the feeling, it shows him what he's doing in a mirror.
Yeah, well, here's the thing, though. But listen to the box you're in as a teacher. This is theoretical, but this is why we're discussing it. If there are small perturbations by definition that you can't see. Now, you saw this one, so obviously it was big enough to make adjustments. But my question is, if chaos theory is correct, and it is operating, but does it apply in this instance, and operating underneath the consciousness, that means that the only way you'd be able to detect these perturbations is the way he talked about, or the way they have designed systems. And I'm just wondering if some of you, and I think the characteristic is, you know they're there if there are resistant errors that all of your attention to can't get rid of. You know then, this is my theory, you know that you're a victim, quote, or that chaos theory is operating, and you have to take steps to get rid of that other than your normal steps, is my point. Yes?
I taught a fighter pilot, a former fighter pilot, for a while. He said when they first started, they would run test missions, and they would come back in the room and they would chart out exactly what happened with each fighter pilot, where each plane was in space and everything. He said as soon as they got a box in the plane that measured rates of space, angles of turn, as soon as they could measure it, he said they got exponentially better instantly.
That's right.
So the more you can measure, Sam, TrackMan, really fine numbers, whether we give it to the student or not, the more measurable information we have, the easier they're going to get better.
Is that in combat or is it line and play?
Just in their measuring.
Yeah.
Practice. Practice.
Then you're not focusing on that.
No, they've done it so much time.
Yeah, and as data mining, now artificial intelligence is huge. Be right there, Joe. Data mining is going to be able to go through all of this information, and there's going to come algorithms that are going to be and they're going to be able to pull out and mine relationships that right now you'd have to run, you know, a Cray computer 24 hours a day for 2 weeks to come out with. But it is coming, in which we'll be able to see whether chaos theory is the dragon in this. Yes.
And I don't know anybody else's feelings. A lot of times I look at this stuff backwards, but exactly what we're talking about, the basis of measurements and baselines that we can go off of. I think as we go forward towards 2040, if we keep running, we try and hit that exact line, I would think it would be smarter for us to go, what's the widest margin for error for success? So that when we know these numbers, it's not an exact. We know it's in this margin and it's in this area. The student's going to have this much variance.
You have to define that.
Rob Neal does.
You got to define that line first, though, don't you?
Yeah, Rob Neal does that already. Yes.
Don't you think, like, I mean, with all the 3D to TrackMan, all this new technology that we have access to, it's like when we first started video. Everybody could overuse a video camera. They could use that technology and misuse it. I mean, isn't our job as a coach to take all this information and make it seem simpler to the student? And then isn't it important to understand, I mean, each player we teach takes in information differently. Absolutely. Isn't it important to know how to dial? Like, some people may love the technical information. They may have an engineering background, and that may be their key to understanding all this, how it works. Then they can go flip that switch, and now I can turn it off and be simple. Sure. But there's other personalities that don't want anything to know about that, because that makes it seem so difficult, so complex, that they get frozen over the walls.
I think that goes back to Ed's point about art of teaching.
Yeah, and then going back to Ed's point about being able to do a static measurement and understand, you know, my body's capable of X, I think that can be misleading. I mean, a static measurement is one thing. Now what happens when you put speed into that program and your muscles take a load?
In 2040, it would be a dynamic.
It would have to be to understand what we were actually capable of doing and to dial each person in. But I mean,
I believe there would be enough research to show people that even your condition, you're only going to be able to do this dynamic.
I mean, we got all this killer technology, not to complicate it.
But you know, I think again, going to the future, at the expert level, to know what the line is, the expert might be able to get to the line. But going back to like Gary's point, who are we teaching out there? And to what level can we expect the guy that's in the office all week long is going to play one time a week, is going to come see you once a month? What are you going to do with that person? And how important is the line that perfectness for him? It's impossible. He's not going to practice enough. He's never going to get there. What can you do to get him to have more fun playing golf? That's really what we're talking about there.
Well, as usual, the last word or summary has gone. Let's hear it for the panel and all of you.